So mean absolute deviation is kind of a way to tell how much range or how much difference the data points have. If it's really small, that means your data is very compact. If that mean absolute deviation gets to be large numbers, it means it goes for a long time. Now, mean absolute deviation that might be large numbers. Let's say we recorded the years where the temperature was on average below a certain temperature. And that might go for hundreds of years or thousands of years back. So we might have a couple of years that were very low, below temperature, and then a bunch of years that were warm, and then a couple more. So we might have some very large numbers. Now, a small mean absolute deviation might be the ounces in a chocolate chip cookie. Because the chocolate chip cookies are made, most of them are about the same size. It's going to be a very small amount. So our mean absolute deviation is going to be very small. So let's start first with the part you've got to start with, which is a measure of center. There are three measures of center. What are the three measures of center? Mode, mean, and median. So the mode is the number that appears the most often. The median is the number, if you line them up, that's exactly in the center. And the mean is the average of all the numbers. So we're going to use mean, which is the sum of the data values divided by the number. So here's our first problem. We've got chickens. They were fed two different types of feed. We want to find the mean weight for the two different pens of chickens. So a farmer goes out, he's raising his chickens, and he's got 10 chickens in each pen, and he feeds them each kind of grain. So here's all the chickens in pen A using premium growth feed. How do I find the mean?
Can't you add them all up and divide by how many there are?
Add them all up and divide it by how many there are. How many are there?
There is
10.
There are 10 chickens. So add all the numbers up and then divide by 10. And we'll find out the average weight or the mean weight of the chickens.
Did everyone else write 58 instead of 5.8?
No, I just forgot to erase what I did earlier.
There's some light chickens in there. Chicken at 5.7 pounds is not much of a chicken.
That won't give me enough chicken nuggets.
He is a nugget.
You would divide up by 10?
And divide it by the total number.
I'm not very good at just sucking on suckers.
Do you want it simplified?
Did you get it?
Or not simplified.
Elena, what'd you get as our mean?
56.72.
Okay, there's a problem. What haven't you done yet? Did you divide by 10?
Okay, even if you did divide by 10, I don't think that'd be right.
Trayson, what do you have?
For just adding at 63.1, and then my answer is 6.31.
6.30 pounds, right? Yeah, that's our mean right there, 6.3 pounds. And if you look, it makes sense. When you're calculating the mean, look across. If I lined all these up, 6.3 is roughly in the middle somewhere anyway, right? All right, so let's look at pen B. We're using maximum growth feed. Let's find the mean weight of the chickens in pen B.
In pounds, why do they put LBS as abbreviation?
I don't know. I'd have to go back and search that.
Why do they put the L there?
You just said he doesn't know. You'll have to look it up.
There's got to be a reason. I just don't know what it is. Okay, but we're more into trivia zone now than we are in math zone. Trayson sounds like he wants to write an essay on why we use LB versus some other.
I feel like it'd be easy, but I don't want to.
one of those things when we get into doing things with a lot of numbers, don't be afraid. Before you hit enter, the great thing about these calculators is you can see what you wrote. So before you hit enter, go back and make sure the numbers are what it says on the paper. Does that make sense? Or the better bet yet even is do it twice and make sure the numbers match.
Pretty sure I got the right thing.
So what?
Oh, excuse me.
So I already checked it and then I divided by
No. Backspace.
I'd say just round it up to 7.
Do it for.
Yeah.
No, what is this?
Now hit enter. Okay, that's the total. Now
Because
divide
if you
by.
notice, he rounded down on the first one.
so
Yeah, before you were just dividing 6.3 by 10, which is why you get such a
In the
big
fight we did?
Now divide by 10.
66 over 5,
Which you
6.8.
What'd you get, Travis?
6.69 or 6.7. Depending if you're running or not.
What'd you get, Josh?
6.69.
6 points. We're going to round it up since theirs are all single digits.
Told you.
We'll go ahead and round it up to 6.7. Did we have to? No. Will it make our life? Generally speaking, if they give you data and that data is to the 10th, your answer given back should be to the 10th, unless they otherwise state it. Okay, so measure of variability. We talked about measures of variability or measures of variance. I've seen it in both. So measure of variability allows us to see how much separation there is in the data. The smaller the separation, the more accurate that average is. The bigger that separation, the bigger that MAD, that mean absolute deviation, the less accurate it is. So we're going to use MAD. So here we've got means, right? 6.3 and 6.7. Same chickens. Let's find the MAD. So what's the difference between 5.8 and the mean we had was
6.3.
6.3? So what's the difference between 5.8 and 6.3? When you're finding difference, you're just doing subtraction, but you're ignoring negatives. So find the difference, Josh. Find the difference between all of these. What's the difference, Travis, between 6.3 and 5.8?
0.5.
0.5. Jason, what's the difference between 6.3 and 6.1? 0.2. All right. Go ahead and find them all. And then I'll come back and ask. I'll give you a chance to find them all.
So, John, you would subtract the mean, the number we got right there, the 6.3, by all of these numbers that it has right here.
So just 6.3 minus 5.5.
And you just ignore all negatives.
Yeah, sure.
So do I like the negatives that you get?
Yeah, if you get a negative, just leave it as a positive.
What do you mean?
So like if you subtract 6.3 minus 6.6, you get 0.3. But we only look for the variability is always a positive number. It's never a negative number.
Still subtract 7.
Let me see what you get.
Okay, I done.
Okay, 6.3 minus
What?
5.5. What do you get?
Why did I just do 6.3
Okay,
minus
do
6.3?
6.3.
It's obviously 0.
Minus
Did I
5.5.
write the number down?
You're at 0, yeah.
It's so stupid.
Minus.
I don't know. Sometimes 0 might be wrong.
Sometimes 0 isn't really 0. What if our life is a
Same thing, 6.3 and 6.6.
Wait.
That was a lie. That was also a lie.
But we're going to ignore negative
Distraction.
numbers.
I'm
It's always
confused.
positive. 0.3.
Unlike
Why
you.
is 6.8 minus 6.3 0.5 whenever 5.8 minus 6?
Because we're doing the variation. You're going to have numbers the same way because we're going how far away from it How far away from the mean is that number?
But how is that even possible?
What do you mean, how's that possible?
I'm confused.
8, 9, 10, and then it would go up to the next number. 1, 2, 3. So that would be 5.8 up to 6.3. And then it would be 6.3. So 3, 4, 5, 6, 7, 8. And that would be up to 6.8. I have big brain.
You all have big brains.
Just so much work.
Just having nothing in them. Josh's brain is filled with Smash Brothers.
I smash brothers.
And math.
A little bit of math. Mainly Smash Brothers and Fortnite.
In the Apex is growing.
And King Boy or Girl.
Jason, what'd you get for these numbers? Under 5.5?
You say Jason or Tracy?
Tracy.
Oh, okay, under 5.5, 0.8,
6.6?
0.3,
7.3?
0.1.
Really?
Is that wrong?
It's just one.
It's just one.
Just
Is
a
it?
whole number.
Oh, maybe.
5.9?
Oh, it is one. I just read it wrong. 0.4,
6.3?
0,
5.7?
0.6,
6.8?
0.5,
7.1?
0.8.
All right. So now to get the mad, we're going to do the same thing we did with the mean, except we're going to add the differences up here and then divide by 10. So add up all these differences, add up these numbers, and divide by 10.
Oh, dude, that wasn't even on the thing.
And then you got divide it by 10.
And divide by 10.
Okay.
Why I put plus zero?
I did.
Or not?
But I did.
Yeah, you can. It fits in there. If you do it, it's not a bad thing to put plus 0. It allows you to see what you're doing along the line. If you start short, and divide by 10 because there are 10 numbers.
I think I divided by one.
Don't you wish you guys had spreadsheets now? Because you can make the spreadsheet do all the work for you.
And then I deleted my answer. Oh, good job, Jason.
All of that. All the spreadsheet and stuff always confuses me.
They're great use once you get to know them. They do awesome things.
I don't get many math teachers that are actually super big into tech.
Tech is math.
Well, math is just everything just about math. Really.
But technology is definitely math-centric and logic-centric. Math is logic. So history is not so much logic. It makes sense, but once you get humans in there, the logic goes weird.
Yeah, it's just human patterns. Really.
Jason, what'd you get as your mad?
0.51.
0.51. And so that's not a bad spread, is it?
No, not really.
So now do B. We know that the mean is 6.7 on this one. Let's find the mad. So go through, find the difference, then add all of them up and divide by the number that's there.
Okay, 1.4. Sorry. Just that I count my out loud. 6, sure how my numbers.
It's fun to say you find your mad. Well, I'm mad already. I found it. Mean absolute deviation.
Yeah, I'm sitting right next to it.
He's not your mad.
He's not my mad. He's the reason I'm mad. Can I do this one more time?
Josh, did you find your mad?
Does that sound about right? Just erase it.
Did you find your mad?
What? What's that about?
This eraser is not very comfortable because it's not soft like I thought it would be.
It's purple together.
This side is softer than the other side.
What's the difference between 6.7 and 5.6? It's 1 point. Right? You just rolled.
Prickly.
It's 1 point.
You barely even put it up to your face and now you know it's never mind.
Same thing. Same thing here.
It's prickly, isn't it?
It's 1.2. Don't lose your
You
ones.
put
No
the,
water. Didn't even tip.
you put the thing.
You keep the whole number, but leave out the negative. Because when we're doing mean absolute deviation, it's always positive numbers.
Nice speaking. Wait. We got one more. Okay. Wait. 6. Oh, that's
We
right.
got the same answer.
I think the 5.4 is 1 point.
Which is why your final came off.
It was off. I asked. And this is also wrong. Wait.
Now you're adding them all together.
The 7.5 is wrong. It's not 9.
What is it?
It's 8.8.
Yeah, that's the thing.
Big brain.
Which one?
The 7.5.
It is 0.8.
I mean, I still got it wrong, but
Me too. That's what I get for using my brain fast.
no one likes using their brain. That was so random.
And I did the eraser. You did the eraser too.
Shh. Behind the back part. That wasn't mine, that was Josh's.
He's scribbling.
You get one?
Is this it?
What'd you get?
0.9.
So Elena got 0.97.
Yeah, that's right.
Now, let's answer number 3. Which pen showed the greatest amount of variability?
Oh, I know.
Which one?
The maximum growth.
Pen B, right? Because the chickens in pen A were much closer to the same weight. The variance was only 0.51.
Why'd you put pin A?
Oh,
Because
it
that's
should-
what hidden was.
No, pin B.
no, it's pen B has the greatest variance. What am I doing? I said pen B out loud and wrote the opposite. That's what I get when I start talking. Because in the middle there I start talking about the weight of pen A, so I just keep writing. So pen B, a lot more variance. The chickens on average are heavier, but the luck of getting a chicken near that weight is a little less. So this is mean absolute deviation. This is how we calculate it. Any questions?